Hey grade 11s and welcome to this video. In this video, we'll be working on the Mathematics Paper 2 for grade 11 and this is from November 2024. This is specifically from Eastern Cape. As usual, the marks allocated is 150 marks and the time is 3 hours. Looking at our instructions, if necessary, round off to 2 decimal places unless they state otherwise. And remember that the diagrams are not necessarily drawn to scale. Also, grade 11s, you guys have an information sheet included at the back of the question paper, at the end of the question paper. Okay, so with that being said, let's get into this video. Question 1 says, after utilizing GeoGebra to teach geometry, the 14 participants' marks out of 100 are displayed in the table below. And we need to write the mode of the data. So the mode is the number that appears the most. So here, what number appears the most? We can see that that is 41. There's no other number that really appears twice. So that is our answer. Moving on to the next question. Question 1.2 says, identify any outlier. So an outlier would be a point that just falls far away, okay, significantly far away from the rest of the data points. So of course, if this was graphed down, right, you would see it like, okay, your points are, following a specific trend. And then an outlier would be like way over there or like way below here. So that is an outlier. Okay, so in this case, if you look at the way the rest of the points are, 16 is quite smaller than these ones. 28 is also much smaller than these ones, but it's not that far away. 16, yes, is still far, but now we see towards the end, 99, that is much far. You could also just calculate and just look at the difference. So which would be more of an outlier? Okay, you would need the mean or the median. You could actually just refer to the median, so the middle of your data set. So we can just say 99 in this case because this would be a value that is much far away from the rest of these other data points. Okay, so 99 is our outlier. Moving on to the next question. Question 1.3 says, determine the median of the data. So the median, the middle value. So if there are exactly 14 participants, the middle would be found in between, if you say 14 divided by 2, but 14 is an even number. So in between 14 would be 7 and 8. Okay, that would be exactly halfway through. You could have also just cancelled like the first and the last, and the second last, third last, and you see that you would get to these two be in the middle. So they lie right in between. And so the median would be the addition of them. So you'd have to add them together. 54 plus 55 divided by 2. And then that will be our median. And so this is equal to 54.5. And that is our answer. Moving on to the next question. Question 1.4 says, determine the interquartile range of the data. So the IQR. You see, we can find the IQR by taking the highest quartile, which is Q3, minus the lowest quartile, which is Q1. Okay, so it's just the range of your quartiles. If you're finding the range in general, you say the max minus the minimum. So this is Q3 minus Q1 because it's the IQR, the range of our quartiles. Well, we know where the middle is. The middle is in between 54 and 55. So if you had to actually put these numbers down as a line, like they all fit in this on this page, okay, and they don't have 2 rows. Okay, if they just had 1 row, then this would be the middle, okay, that in between 54 and 55. So that would mean the first half of your data set would be all of these numbers. So Q1 would be the middle of the first half of your data set. So because we have 7 numbers in the first half, we know that the number right in between would be the 4th number, this number 41. Okay, so that is Q1. And then to find Q3 would be marked at, so the middle of the second half of our data set, which we can see is at 60. So this is Q3. And so we can just go ahead and say that Q3 minus Q1, which is 60 minus 41. And so 60 minus 40 is 20, so minus 1 is 19. And so our IQR is 19. And moving on to the next question. Question 1.5 says, draw a box and whisker diagram using the number line provided in the answer book. Okay, so I'm just going to have to draw a number line down. So with this, we already have Q1, we have Q3, we have the middle. Okay, we know now the middle is 54.5. That is Q2. And we can see that the minimum value is 16 and the maximum value is 99. So let's draw our number line and, just put it in a way that it helps to, put down these values. They don't have to be, all visible on that line, but at least they should be able to fit. So it's 16, 41, not very good numbers. So I'll just draw down a number line and just make sure that those numbers are actually pointed out. Okay, so I'm using the number line from 10 to 100. And we can see that the minimum is 16 and the maximum is 99. So 16, we have 10, and so 16 will be probably somewhere here. Okay, so let me actually just draw it so that we use this line as the line that will connect it. Okay, so 16, and then just make sure that you do state that this is 16. Okay, so I'll just write that up here. Say that that is 16. That's the minimum. And then the maximum is 99. So that's just close to 100. And we're just going to put that there. Okay, 99. I'll just push it more. And then our Q1. Q1 is 41. So here's 40 and then 41. So Q1 is 41. We're just going to draw a line down here. And then Q2 is 54.5. So that's 54. It's basically like halfway, almost halfway. So this is 41. This is 54.5. And then lastly, Q3 is 60. So I'll just say that that is 60 over here. Okay, and now we can connect. So we're going to connect our 3 quartiles, okay, and they form a box. And then the whiskers are created by that minimum and the maximum value. Okay, so there we go. As long as everything is pointed out, it's fine. And this is our box and whisker diagram. Moving on to the next question. Question 1.6 says, comment on the skewness of the data by using the box and whisker diagram. Okay, so based on the box and whisker diagram, how can we say this data is skewed? Okay, is it skewed to the left or to the right? You can do this by looking at the quartiles. So we're looking at Q1, Q2, and Q3. So if Q2, and let's actually just look at it like this. Imagine you're standing, and if you were standing and you were facing front, okay, the front. So this would specifically be your right-hand side, and this would be your left. If you notice that Q2 is closer to Q3 than it is to Q1, then this is skewed to the left. And if Q2 is closer to Q1, then it's skewed to the right. So in this case, it is skewed to the left, okay? Because we can see that it's moving towards Q3. It's closer to Q3. So we can tell them that the data is skewed to the left, or you could also say negatively skewed. Okay, and that is our answer. And that is it for question 1. Question 2 says, the height of the boxers who underwent fitness and health checks is shown in the frequency table below. Okay, so we've got their heights and the frequency. So the frequency would be how many boxes fell into each class. Okay, 1 box in that class, there are 3 boxes in this class, and so on. And 2.1 says, complete the cumulative frequency column provided in the table in the answer book. So we can just complete it over here. So to complete this column, it's very simple. You simply just drag the first number, that's just 1, okay, because you're adding 1 to nothing, it's just 1. And then it's 1 plus 3, which is 4. And then 4 plus 9, which is 13. And 13 plus 6, which is 19. 19 plus 3, 22. And then 22 plus 1, 23. Okay, and there we go. We've completed the cumulative frequency column. Moving on to the next question. Question 2.2 says, write down the total number of boxes. So we see that these are the boxes that we have. You see how we kept adding all these numbers? And so we really just added everything here. And so that adds up to a total of 23. So it means that there are exactly 23 boxes. And that is our answer. Moving on to the next question. Question 2.3 says, estimate the mean of the boxes. So the mean, we need to find the average. So do you see that we have group data? So these data points are in classes, okay? We can't really see, for example, in this category, we can't really see the individual weights of these boxes. We can't just see that, oh, okay, there's one boxer here who weighs about 65 and another boxer who weighs about 71. We can't see that. They've just grouped them into these categories. So normally, if we were able to see that, we would just take all their weights, take all the weights of the boxes, add them together, and we would simply say divided by the total number of boxes. But because we can't do that, we can't really see that, we are going to estimate. We're going to make an estimation when using the weight of the boxes. So there's an additional column that we're going to need, and this is really 2 columns that we need. The first one would be the midpoint. And the midpoint we're referring to is, it's just the midpoint of this class, okay? So we know that the boxes that are here are boxes who weigh more than or equal to 35 and then less than 55. But to just get a middle or an estimation, we're going to say 35 plus 55 and then divide by 2. And then that's what we're going to use for all the boxes in this category, that specific weight. Okay, so that's going to be 90 divided by 2, which is 45. So we'll say 45 there. That's what we have. And then here, 55 plus 75 divided by 2. And so we have 130 divided by 2, which is 65. So 65 and so on. So we're just saying this first number plus this number divided by 2 all through. Okay, so there we go. And now to find this mean, here's how we're going to do this. We made an estimation here. So it means that in this class, we're going to use 45. I think these are kgs. They didn't really say so. But we're going to use 45 kgs for everybody here. So then we will say this midpoint that we just found, right? That midpoint, and we would multiply it by the frequency. Here is why. Okay, just look at this class, for example, right? This class over here. There were 3 boxes that weighed between 55, okay, to less than 75. You can't just say, okay, here we're going to just take 65 kgs and that's all. It's 65 kgs, but weighed by 3 individual boxes. So we're going to have to say 65 times 3. So that would be the total kgs in this, or the total weight in this category, okay, in this class. So we're going to take the frequency, multiply by the midpoint. So here it's just times 1, it stays 45, and then 65 times 3, and 85 times 9, and so on. I'm going to put those numbers down here. And now we have all their weights. Okay, so remember how the mean is calculated by, but this is specifically the estimated mean. But remember how the mean is calculated simply by taking all the data points, right? Adding them together and dividing by the total number of points we have. In this case, the total number of people or boxes. We're going to do that. So we have all their weights now. So these are their weights. We're going to add this up together and then divide by the total number of boxes. So this is still the estimated mean that we have. Okay, so let me sum them up. Okay, so all of this divided by the total 23 boxes that we have. And let's add them up. Okay, so that is 2,155 divided by 23. Make sure that you show this number so it shows that you did add them up. And if you take that and you divide it by 23, how much do we get? We get 93 point, and that's going to round that 5. Okay, that 5 is going to round the 9 up, and then that will add to the 6. So you can say 93.7 or 70, that's fine. And that is the estimated mean. Okay, moving on to the next question. Question 2.4 says, use the grid provided in the answer book to draw a cumulative frequency graph, the ogive, for the data. Okay, so let's go ahead and just put our values down. So you have a graph already if you find the answer book. So we're going to just use that to draw the ogive. But here's something that you need to take note of. These, okay, are the weights and then that's the cumulative frequency. So we're using these two columns. But please take note that whichever number you start with here, okay, this 35, this x value will go with a y value of 0. Okay, so where y is equal to 0, that's going to be your x-intercept. That's going to be on the x-axis. And then the 55, that will go with this cumulative frequency value of 1. The 75 will go with the 4. And then the 95 will go with the 13, and so on. Okay, so here is our graph, and we're just going to draw down these values. Remember, we have this 35 and 0, right? They go together. So 35 and 0, so that point must be grounded there. And then we have 55 and 1, 75 and 4. So 55 and 1, we'll just put 1 over here. Okay, and then 75 and 4, that's just below 5. So, and then I'll just fill in the other points that we have as well. Okay, so there we go. And then we're just going to draw our ogive. So connect these dots, and it's going to be a curve like that. Okay, so there's our ogive, and moving on to the next question. Question 2.5 says, it is further given that for a boxer to qualify for the next upcoming match, he must have a mass that is in the interval of 75. Okay, so greater than 75 but less than or equal to 100. Using the cumulative frequency graph, the ogive, estimate the number of boxers that will qualify for the next upcoming match. Okay, so we can only use it because you see that this one ended with 115, so not 100. So using the ogive to find out the boxes that will qualify. You qualify if you fall within this amount. So using the ogive to find out the boxes who qualify, we're just going to go here, right, to 75. Because we know that they're between 75 and 100, we'll go to 75 and then 100. Yeah, we need to find out what 100 is. But with 75, we already know what this is. Okay, using the cumulative frequency, we knew that this was 75 and 4. So we know that this is 4. Okay, great. Now we need to find 100. Okay, so using the ogive, let's say 100 looks like it could be around here. So this would be, you'd go from 100 straight up to the ogive. So 100, yeah, I'm just going to take where it intersects right there. So that would be at 100. So we're saying that this is 100 over here. The cumulative frequency value that we have, the total number of people here that weigh 100 or less than 100 are exactly 15. So to find out the people who would qualify between 75 to 100, you're going to say that this is 15, okay, minus 4. The total people who weigh 100 or less than 100 are a total of 15. But the total people who weigh 75 or less than 75 are 4. So that difference would give you the people between 75 to 100. Okay, so that is about, remember, there are a range of values that they will accept. So that is 15 minus 4, which is a total of 11 boxers. And that is our answer. And that is it. 11 boxers would qualify for the upcoming match. And that is it for question 2. Question 3 says, in the diagram, P, which is X and Y, Q, -2 and 2, and R, which is, wow, okay, 2 and 3 or 3 and 4. Okay, let's just see. With 2 and 3, it could be either one. We're going to just have to see. Okay, so there's a little bit of a confusion here. It could be 2 and 3. It could be 3 and 4. I was looking in the rest of the question if there's like any indication of, show us any right angle or anything like that that could help to determine what exactly it is. But it seems like it could be any of it. So I'm just going to use it as 3 and 4 in this case. Okay, so let's just go ahead and leave it as 3 and 4. So that is R. We'll keep that in mind. So these are the vertices of triangle PQR. And we are told that line PR passes through the point of origin at O. The equation of the line PQ is given by this equation and let's just put that down. So PQ's equation is already here. This is PQ. Its equation is y equals 6x plus 14. And they tell us that S is the x-intercept of line QP. So S is the x-intercept. Okay. And the first question is just to calculate the gradient of PR. Okay, all you need are your formulas. So PR, the gradient formula is y2 minus y1 over x2 minus x1. Okay, so looking at PR, if this is P and that's R, you see that we can't use P, okay? But they did tell us that this line passes through the origin. PR passes through the origin. So you can just use 0 and 0 and 3 and 4. Okay, so just follow one order. Either you're saying the values of O, right, minus R or R minus O. So I'm going to go ahead and take top minus bottom, meaning the y value of 4 minus 0 over the y value of 3 minus 0. And our gradient of line PR is therefore equal to 4 over 3. And that is our answer. Moving on to the next question. Question 3.2 says determine the equation of PR. Okay, so PR, we have its gradient. And remember that the equation of a straight line is in the form of y equals mx plus c. We know the gradient is 4 over 3. So just 4 over 3 x plus c, and let's just look at what c is going to be. Because we already know that this passes the origin, all this means is that the y-intercept, because this is where it intersects the x and the y-axis, so the y-intercept is 0. And you know that your y-intercept is this part c, okay? Because when we're trying to find the y-intercept, this is where x is equal to 0. So if you make this equal to 0, all of this just becomes 0 and you're left with c. Okay, so we know now c is just equal to 0. Therefore, the equation of this line is simply y equals 4 over 3x. And that is our answer. Moving on to the next question. Question 3.3 says, determine the coordinates of P. So how can we find P given everything we have? Well, we just found the equation of PR and we already know this equation. So it's always good to put down whatever you have been given because it's going to help you throughout the questions. So because this point P is also the point of intersection of this line PQ and PR, we can just equate the equations to find out where they intersect, and that will be P. So let's go ahead and say y is equal to y, and we can just, well, this one looks like it's going to be bigger. Okay, so 6x plus 14, we have 6x plus 14 is equal to 4 over 3x. And now we can solve for x here. So when we transpose, we have 6x minus 4 over 3x. And we can just put that over 3 by making it 18 over 3x. So 18 minus 4 is 14. So you end up with 14x. It's not necessary. You can just write it immediately. 14 over 3x is equal to, and we transpose, and that's negative 14. So to get rid of this 14 over 3, you can decide to divide both hand sides by 14 over 3, but you could also just multiply both sides by 3 over 14. And then that will get rid of that numerator and the denominator. So what you do on one side, you must do on the other side. So it's also times 3 over 14. And now we have, therefore, x is equal to, these cancels, the 14s are gone, but you still have the negative 1 and the 3. So they multiply and give you negative 3. So we know the x value, right? It's negative 3. So to find the y value, remember, this point lies on both lines. So you can substitute it into either one of those equations. Let's just go with this one because it's easier. So we can say y is finally equal to 4 over 3 multiplied by negative 3. That's in the numerator, that's in the denominator. They would cancel and we have negative 4. So P is simply negative 3 and negative 4. And that is our answer. Moving on to the next question. Question 3.4 says, determine the coordinates of S. So where is S? S lies on, as we can see, the x-axis, and it lies on this graph. So if it lies on the x-axis, it is an x-intercept. And to find an x-intercept, you simply make y equal to 0. So let's take that equation, 6x plus 14, and then make y equal to 0. So in place of y, we make this 0. And you can just transpose the 14, that's fine. So that's going to be negative 14 equals 6x. Or you could just say 6x equals negative 14. And divide both hand sides by 6. Therefore, x is equal to, they are both divisible by 2, so that becomes negative 7 over 3. And that is our answer. So the coordinates of s, because it's an x-intercept and y is equal to 0, the x value is negative 7 over 3, and the y value is 0, and that is our answer. And that is it for question 3. Question 4 says, in the diagram, triangle ABC is drawn with the vertices A, which is negative 7 and 0, B, 3 and 8, and C, which we can see is on the x-axis. Okay, P is the midpoint of line AB, Q is a point on line AC, and AQC is a line on the x-axis. E, which is negative 1/2 and 2, is a point on line PQ, and we are also told that PQ is parallel to BC. Okay, so first question says, calculate the coordinates of P. So what did they tell us about P? They said P is the midpoint of AB. So we need our midpoint formula. The midpoint is, we'll find the midpoint by saying x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And now our point P, we'll just substitute those values. So the endpoints are A and B. So A can be negative 7, that x value, and then plus 3 over 2, and then 0 plus 8 over 2. And just simplify. So P is finally, that is going to give us a negative 4 divided by 2 is negative 2. 8 divided by 2 is 4. And that is our answer, negative 2 and 4. Moving on to the next question. Question 4.1.2 asks us for the gradient of AB. And these are 2 points that we already have. Also, let me just make sure to put down this point P because it's probably going to be useful in the next questions. Okay, so let's find AB. We'll just put our points down and find the gradient of this. So the gradient is equal to y2 minus y1 over x2 minus x1. You don't have to write that again. That is fine. You don't get a mark for writing the equation. Okay, because grade 11s get a formula sheet now as well. So you can choose to go in any order. You can say top minus bottom or bottom minus top. I'm just going to go with top minus bottom. So the y values, 0 minus 8 over negative 7 minus 3. And this is the gradient of AB. So simplify this. We can see that this stays negative 8 in the numerator and we have negative 10 in the denominator. So our final answer for the gradient of AB is simply equal to positive, and we can see that there's a common factor of 2 here. So this is positive 4 over 5, and that is our gradient. Moving on to the next question. Question 4.1.3 says find the size of alpha. So we can see that alpha is the angle created between the x-axis and this line AB. So it's the angle of inclination of AB. So all we need to find this is the gradient of AB, which we just previously found as 4 over 5. So to find the angle of inclination, we simply say tan theta is equal to our gradient. Okay, so we know that the gradient is 4 over 5. So we're simply going to say tan theta is equal to 4 over 5. And then to find that answer for theta, we'll simply just take tan over. So we're using the second function of tan. So this is 4 over 5, shift tan 4 over 5, and then let's just find out what that is. So shift tan 4 over 5 is simply equal to 38 point, and that is going to round up to a 6. And you can just leave it like that, that's fine. So 38.66 degrees, and that is our answer. That is the size of theta. Moving on to the next question. Question 4.2 says, determine the equation of BC in the form of y equals mx plus c. So we need to find the gradient and then at least 1 point that can help us to find that y-intercept. So looking at BC, BC is this over here, and we only have B. Okay, so we don't have C, But you see that BC is parallel to PQ. So because they're parallel, their gradients are the same because they're slanted in the same way. Okay, they're sloped in the same way. So we could just find the gradient of PQ. Now, though we don't have Q, we do have E. What do they tell us about E? They said that E is a point on the line PQ. So we can use P and E to find the gradient of PQ. Okay, so let's go. We're just going to say, to find this gradient of PQ, we'll just say that the gradient of PE is equal to the gradient of PQ. And we also know, of course, that's going to be equal to the gradient of BC since those lines are parallel. I'm just stating this initially. Okay, it's equal to the gradient of BC as well. So let's use P and E. P was this point. We'll just put the points down first. Okay, so the gradient of this line PE is equal to y2 minus y1. So we can say 4 minus 2 over x2 minus x1, which is negative 2 minus negative a half, which becomes plus a half. So in the numerator, we get 2. In the denominator, we get, that's going to be negative 3 over 2. Okay, so negative 3 over 2 divided by negative 3 over 2. And if you use a calculator or you use tip and times, if you are dividing by a fraction, you can simply just switch the numerator and denominator and then turn this division into a multiplication. So that's just going to give us negative 4 over 3. Okay, so that's the gradient of PE. And so therefore that is the gradient of BC as well. So we can tell them that the gradient of BC is simply equal to negative 4 over 3. And to find the equation now of BC, we need one point that lies on BC. So their gradients are the same. And now to find this equation, you can simply use B since this lies on BC. So that's 3 and 8. So this is 3 and 8. And you can either use y equals mx plus c, or you can use this formula. So we can say y minus y1 is equal to our gradient, which is negative 4 over 3, times x minus x1. And our y1 and our x1 are the points we're substituting. So that is 3 and the y value is 8. So y minus 8 is equal to negative 4 over 3 times x minus 3. And we can simplify. So this is negative 4 over 3x. And that becomes positive. Well, if you have negative 4 over 3, right, and you're multiplying by negative 3, in the numerator and denominator, you see those cancels. So we just have positive 4 over there. And then if you transpose the 8, it becomes positive 8. So that's 8 plus 4, which is 12. And so y is simply equal to negative 4 over 3x plus 12. And that is our answer. Moving on to the next question. Question 4.3.1 says, calculate the length of AC. So we didn't have C, but we do know the equation of this line BC now. And you see that C is on the x-axis of this line BC, meaning this is the x-intercept. Because it is the x-intercept, we can simply find it by making y equal to 0 in this equation. So just using the previous question's answer. Okay, so we make y equal to 0. And in this case, you see this is negative. We can just transpose it. So it's now positive 4 over 3x is equal to 12. And to solve for x, you can divide both sides by 4 over 3 or multiply both sides by 3 over 4. So 3 over 4 and 3 over 4. So that is now x is equal to, we can see that 12 and 4 have 4 in common. So divided by 4, we get 3 there. Divided by 4, we get 1 there. So that's 3 times 3, which is 9. You can also use a calculator. So x is equal to 9. And now we know what c is. So c is this x-intercept, 9 and 0. And we just need a so that we can find the length of AC. So a, okay, is negative 7 and 0. If this is 9 and 0, this is a horizontal line. You don't have to use the distance formula in this case because it just means that from the origin, you went exactly 7 units to the left to get to A and exactly 9 units to the right to get to C. So 7 plus 9 would be the length of AC. Or you could have seen this as the higher x value minus the lower x value. So to find AC, the length of this horizontal line AC is equal to positive 9 minus negative 7. Okay, so that is 9 plus 7, which is 16. And so it is 16 units, and that is our answer for the length of AC. Moving on to the next question. Question 4.3.2 says we need to find the area of the trapezium PBCQ. Okay, so PBCQ, and let's just highlight that first. So that's from P, B, C, and Q. Okay, so we need to think about this. You see, this is a trapezium. We could use the formula to find the area of a trapezium, but in this case, you see, the trapezium needs to have a height, a visible height, and then we can actually do that. So let's say our trapezium looked like this. Then we could have found the area of this trapezium by looking at the top part, the bottom, and then the height. Okay, and the perpendicular height specifically, that's over there. And in this case, we would find that area by taking the top plus the bottom, and then just say divided by 2, and then multiply by the height. And then that would be it. But we have a weird scenario here because we can't see any clear visible height. We can't see any perpendicular lines. Okay, we could find out whether we do have perpendicular lines because we have the gradient of AB and BC as well. The gradient of AB we found in the second question, which was 4 over 5. And if you take 4 over 5 and you multiply by, let's see, the gradient of BC, which we already found. The gradient of BC was negative 4 over 3. Okay, so if you multiply those, you can already clearly see they're not going to give you negative 1. If these lines were perpendicular, like they formed a 90-degree angle, then the gradients multiplied should give us negative 1, okay, because that's a property of perpendicular lines. So we clearly can't really use that, and we can't even find the area as a trapezium. But look at what we could do. We could find the area of triangle ABC, and if you subtract that area, that entire area, because it's going to be everything here, and you say minus the area of the triangle APQ, then you'll be left with the area of this trapezium. So in this case, it's just best to go with this. So we're going to find the area of triangle ABC and then minus the area of triangle APQ. So let's find them separately, ABC and APQ. Okay, so these are the two triangles we'll focus on. So in this case here, this is how we can find it. To find the area of a triangle, we say a half multiplied by the base multiplied by the perpendicular height. So in this triangle ABC, okay, where's the base? We can take AC as the base, and that is great because we already have the length of AC. And then where is the perpendicular height? Well, you can't just say, oh, okay, maybe it's BC. That's not the height. That's not how high this triangle is. You're going to have to go from the highest point of the triangle, and we're going to go down to this base. And that height needs to be perpendicular to the base. So we can see that the height here is exactly how many units? Okay, from the ground, from the x-axis all the way up here, we went how many units up? We went 8 units up. That's why B is 3 and 8, okay? 3 to the right and 8 up. So it's 8 units. And so that's the height. We know the height and the base of triangle ABC. Let's put that down. So the perpendicular height is 8 units, and that base AC is 16 units, which we found previously. And now let's look at the triangle APQ. So with triangle APQ, we can see that the base would be AQ. Now, how do we find AQ? Okay, you're going to have to look at this bigger triangle because we have a specific theorem going on here. So do you see that initially they've given us that AP is equal to PB. So we have P as the midpoint. And then these two lines are parallel. Okay, PQ is parallel to BC. That means that we can use the converse of the midpoint theorem to conclude that AQ is equal to QC. And of course, that would mean that BC is twice the size of PQ. But we don't really need PQ, so it's still fine. So if we have the full length of AC and we know that AQ is equal to QC, it's just half the size of AC. This is using the converse of the midpoint theorem. So let's get AQ, and we can just say that the length of AQ, that base of our triangle, is equal to half of whatever AC is. And we knew that AC was this base, okay? So that's 16 units. This is AC. So if this is 16, it means that AQ is simply 8 units. Okay, so we have that there. And of course, if this was Euclid, we would say this is because of the converse of the midpoint theorem. But this is not really Euclid. You don't really need those reasons. Okay, so now that we have that down, what is the height of this triangle, okay, of APQ? The height of triangle APQ, you're going to have to go from the highest point of APQ down to the base and ensure that the line is a line perpendicular to the base. Now, funny enough, you can actually use the area rule here. Okay, the area rule you learned in trigonometry, okay, 2 and 3D trig. So here we're just going to use this. Okay, so we know that P is -2 and 4. So that just means that the height of this triangle is, okay, that y value of P, which is 4, because to get -2 and 4, you went 2 units to the left and 4 units up. Okay, so we know it's exactly 4 units. So that is the height of PQ. So the perpendicular height is 4. And now we can go ahead and find this. So the area of triangle ABC, you can actually just find it together. That's fine. So we'll say that the area, to find the area of this trapezium, PBCQ, we simply say a half multiplied by the base. Okay, so we're taking the area of, it's better to just say the triangles, the area of triangle ABC minus the area of triangle APQ. And so this is equal to, we're just going to say this area of triangle ABC is found by saying a half multiplied by our base, which is AC, and that's 16, multiplied by our height, which is 8. And then we're going to say minus the area of APQ, which is a half multiplied by the base, which is AQ, that is our base, and that is 8 units, multiplied by the height of 4, the perpendicular height of 4 units. Okay, and let's just find the areas separately first. So this area will give us half of 16 is 8, and then 8 times 8 is 64. And then we have minus, so these are in squared units, and then we have 16. And then it just is equal to 48. So this is 48. I'm going to say units squared. And that is our answer. And that is it for question 4. Question 5, 5.1 says, if -3 tan beta minus the square root of 5 is equal to 0 and sine beta is less than 0, and then straight away you can already see they're giving you information about a trig diagram. And they say, determine the value of sine squared beta minus cos squared beta with the aid of a diagram. Okay, so let's go ahead and put our cost diagram down. Remember, grade 11s, how you draw this diagram is we start with our angles so we can understand which quadrant certain angles will lie in. But of course, it's not really that important here just because of the kind of information they've given you. So for this one, we can skip those angles. And let's take the first piece of information they've given us, which is -3 tan beta minus the square root of 5 is equal to 0. Now, to better understand where this terminal arm or where this diagram is going to lie, we need to find out the value of tan beta. Okay, so we're going to leave -3 tan beta on the left, and then let's transpose this -√5. So it's going to be equal to the positive square root of 5, and now we can divide both hand sides of this equation by -3. So this means that tan beta is equal to negative square root of 5 over 3. Okay, so this fraction is negative. So this means that tan is negative. Tan beta is negative in this specific quadrant. Let's think about where tan is negative. So everything is positive in the first quadrant, only sine is positive here, only tan is positive here, and then cos is positive here. So where tan is negative would be in sine's quadrant and cos's quadrant, okay? Because that is where sine and cos are both positive. Okay, tan wouldn't be positive in any of these. But then they also give us another piece of information, which is that sine beta is negative in this particular quadrant, less than 0. So Between these two quadrants we have selected, where is sine negative? That would be in cos's quadrant. So in the fourth quadrant, and that's where our terminal arm will lie. So we're just going to go ahead and draw the arm, and this goes up to the x-axis. So line up to the x-axis, and it is perpendicular to the x-axis. Okay, and now we're going to fill in this diagram. We know that tan beta is equal to negative square root 5 over 3. But remember that from SOHCAHTOA, right? Tan is opposite over adjacent. So this is the opposite side and this is the adjacent side. Now, we can't just assume that this is the negative one or this is the negative one. We're going to have to see based on the diagram which would be negative. So if this is beta, it means that because this lies in the fourth quadrant, beta is measured from that first quadrant, okay? We measure anti-clockwise all the way to here. So we'll say this is beta. And now we can see that the opposite side, the side opposite this angle, would be root 5, okay? And then the side adjacent would be 3. So clearly, which one should be negative? In this case, yes, it is the root 5 that is negative. But always just make sure that you look at that to just ensure that you have given the negative to the correct side. Okay, so with this, you can see that all we have to find is that radius. So we can use Pythagoras to do this. So r squared is simply equal to, and we'll say that is 3 squared plus negative 5 all squared. And then we'll find out that r squared is equal to, this will be 9 plus 5, which is 14. And now we have square root both sides, and therefore r is simply just equal to the square root of 14, because we know that there is no, perfect square number here. Okay, so that is r. It is the square root of 14. And now we can finally find what they were asking us to find, which is sine squared beta minus cos squared beta. So this is equal to sine squared beta. We would take from SOHCAHTOA, sine is opposite over hypotenuse. So that's the opposite over this hypotenuse. Okay, so we're going to say that is negative square root 5 over the square root of 14 all squared. And then minus cos squared beta is adjacent over hypotenuse. So that is the 3 over the square root of 14. So minus 3 over root 14 all squared. Okay, so you can see that from this, the roots will break open and the negative becomes positive when it's squared. So we have 5 over, the root breaks open there, 14 minus, and here we have 9 in the numerator. And when this is squared, it becomes 14. And 5 minus 9 is negative 4. So this is negative 4 over 14. We can see that they have 2 in common. So our final answer is negative 2 over 7. And that is it for question 5.1. Moving on to the next question. Question 5.2 says, if cos 49 degrees is equal to k, determine the values of the following in terms of k. Okay, so cos 49 degrees is equal to k. What are these in terms of k? This is also a trig diagram. Okay, it can be a trig diagram. You can answer it with, well, it's not going to be that easy depending on what they ask you. But the easiest way to deal with this is to actually draw a diagram. They specifically gave you the value of cos 49 degrees. If you look at the angle 49 degrees, which quadrant does that lie in? That lies in the first quadrant because it's an angle greater than 0 degrees but less than 90 degrees. So it's in the first quadrant. So you draw your terminal arm here and then it's a line down to the x-axis perpendicular to the x-axis. Okay, so that is our 49 degrees over there. And if we look at this, this says cos 49 degrees is equal to k. Remember from SOHCAHTOA, right? Cos is adjacent over hypotenuse. If cos 49 degrees is equal to k, then it means that k is the adjacent and then the hypotenuse is its denominator. Now, it clearly doesn't have a visible denominator, so it means that that denominator is 1. Okay, so what we have here is the hypotenuse length is 1 and the adjacent side is k. So all we would need to find would be the opposite side. Again, using Pythagoras since we have a right angle triangle. So we can go ahead and just say to find that opposite side, we can just call that, let's just call it y, okay? Because it's really a y value. When we find it, that's a y value. So y squared is equal to the hypotenuse squared. The hypotenuse is 1, so that's 1 squared, minus the adjacent side squared, which is k squared. And now, when we want to solve for y, we need to square root both hand sides. So if you square root and you square root, you have y is equal to the square root of, now I know this should be positive or negative, but you see that the y value is positive in the first quadrant. Okay, so we can just leave it positive. So 1 squared is 1, and then minus k squared. Okay, so y is equal to the square root of 1 minus k squared. And now we can find the value of sine 131 degrees. So you're going to have to ensure that this ends up relating somehow to 49 degrees. So sine 131, well, it's first an obtuse angle, so we can reduce it to become an acute angle. And you can see that this would be an angle that lies in the second quadrant, okay? Greater than 90 degrees, but it is less than 180 degrees. So we're going to use this reduction, 180 degrees minus theta, and it is in the quadrant where sine is positive. So this is sine 180 degrees minus what gives us 31 degrees. Well, 180 minus 49. So when you reduce this, because we're using sine and it is in sine's quadrant, it will stay positive. So this is positive sine 49 degrees. And we have our diagram, so we can actually find this. So sine 49 degrees, we're going to take the opposite over the hypotenuse. So that is simply the square root of 1 minus k squared over 1. But if you divide anything by 1, it stays the same. And so that is our answer. Moving on to the next question. Question 5.2.2 says we need to find the value of 1 minus cos squared 41 degrees. Okay, you see 41 degrees and 49 degrees. If you add them up, you get 90 degrees. Okay, so that means we can use cofunctions here. Okay, now I don't want to just immediately change this because you see 1 minus cos squared of an angle, that is one of the identities that we have. You see from sine squared theta plus cos squared theta is equal to 1. If you made sine squared theta the subject, you would just do that by taking cos squared theta over, so it becomes negative cos squared theta. And do you see now that we can actually change this to sine squared 41 degrees? Okay, now we know that 41 and 49 add up to 90 degrees, so we can use cofunctions on this. So to change it to its cofunction, sine 41 degrees is equal to cos of 90 degrees minus this angle. Since they're acute, okay, it's already an angle less than 90 degrees. We don't have to consider any changes in the sign that we have. So this is simply just cos squared 49 degrees. And so what is cos 49 degrees? We were already told that this is k. So if this is k, then cos squared 49 degrees is simply k squared. And that is our answer. Moving on to the next question. Question 5.3 says, simplify the expression to a single trigonometric ratio of x. And let's go. So we have tan 180 degrees minus x. This, let's just get the cos diagram down here first. Okay, so tan 180 degrees minus x, and you can see that 180 degrees minus theta, that is in sine's quadrant. Okay, so tan is negative here, so this becomes negative tan x. And this is multiplied by cos negative x. When your angle is negative, you can simply just add 360 degrees, okay, to it. So when you do that, you get positive cos 360 degrees minus x. And when you want to reduce this angle, do you see that this is in cos's quadrant? So cos is positive here, so it reduces to positive cos x. And then we have plus and sine squared 360 degrees minus x. 360 minus x is in cos's quadrant, where sine is negative. So this will become negative sine x, but it's squared. So it ends up getting squared and just staying positive sine squared x. And then we have a cofunction, cos 90 degrees minus x. And you see that it is at 90 minus x. The only one that becomes negative is that cos 90 degrees plus x. That becomes negative sine x. Okay, so this simply just becomes positive sine x. And this goes all over. we have sine 180 degrees minus x, which is in sine's quadrant, so it stays positive. So positive sine x. And now all we're doing is just simplifying. Okay, so we've got, just look at the amount of terms you have in the numerator. Terms are separated by plus or minus signs. Here is this separating. So we have two terms here. We have to simplify that and simplify that separately. And then we'll be able to finally just work with it all together. Okay, so with tan, we know that tan's identity is sine over cos. So this becomes negative sine x over cos x. And it's still multiplying by a cos x. So this cos x in this numerator, okay, when we're looking at it like this, it has a denominator of 1. So do you see that? It's going to cancel with this cos x over here. Okay, and then we still have this plus, and we have sine squared I. Well, you can just multiply them. They will just become sine cubed x, okay? And now we have over sine x. And if you just simplify this, you have negative sine x in the numerator. That's all that is left. And you have plus sine cubed x over sine x. And clearly we can see that there is a common factor of sine x all through. So we have that common factor and we'll just take it out. So sine x is common and we have what left in the first term. If you say negative sine x divided by sine x, you simply get negative 1. And here, if you say sine cubed x divided by sine x, you get positive sine squared x all over sine x. And we can see that they will both cancel in the numerator and denominator. And so now we are simply just left with negative 1 plus sine squared x. Does that look familiar? Yes, okay? Because it looks a lot like the identity for cos squared x, which is 1 minus sine squared x. But the only difference is here, the 1 is positive, here it's negative. Here the sine squared x is negative, here it's positive. So it just means that there's actually a common factor of negative 1 here. And if you take it out, then you have positive 1 left. And then what is left in the second term? That is negative sine squared x. And now we can see that is actually identical. So this becomes cos squared x. So this is negative multiplied by cos squared x, which is negative cos squared x. And that is our answer. Question 5.4 says, simplify without the use of a calculator. Okay, so let's just see, the flow of things here. We have sine negative 15 degrees, but cos 75 degrees, tan 75 degrees. Okay, so you see there's a repetition of 75 degrees and 15 degrees and another angle that can still be represented as 15 degrees. So this is definitely using cofunctions because you see that if you say 15 degrees plus 75 degrees, that gives you 90 degrees. So these are cofunctions that we're using here. But we just have to decide on which angle to keep. Do we want to stay with the 75 degrees or the 15 degrees? I'm just going to stay with 75 since, there are more 75s here. You can also decide to change it to 15 degrees. It's still fine. So we have sine negative 15 degrees and you see the angle is negative. So you can simply add 360 degrees to this. So add positive 360 degrees and we have 360 degrees and this 15 degrees is still negative. So you can see that the reduction we can use here from the previous question, I'll just get this down. Okay, that reduction we can use is this reduction over here, okay, in cos's quadrant. So sine is negative in cos's quadrant. So this will simply simplify to negative sine of 15 degrees. And I'm going to change that to a 75 degrees soon. So multiplied by, and then we just still have cos 75 degrees and then plus tan 75 degrees. Now tan, we can rewrite it as sine 75 degrees over cos 75 degrees, just so it cancels with the next cos, okay? So multiply by cos 75 degrees. And then we have cos 165 degrees. It's already an obtuse angle, so we might as well just reduce it. So reducing it, we're going to say cos 180 degrees minus what gives you 65 degrees. And that is 180 minus 15 degrees. This reduction, cos 180 degrees minus theta, is in science quadrant where cos is negative. So this becomes negative cos 15 degrees. Okay, and that's still fine. So we don't really need this for now. We can just remove that. Now, with this, another thing to take note of is the amount of terms that you have here. When simplifying expressions, you simplify them term by term. So we have a plus here. Okay, and this is the main thing separating. You can't say this is a separator because these two are multiplying. Okay, so you're just saying we are multiplying here. So that is not separating. This is what is separating the terms. So it means that this is our first term and we need to simplify that first term first, and then we can get to the other terms. So I'm trying to focus on sticking with 75 degrees throughout. So we're going to go ahead and change the sine 15 degrees using cofunctions. So if you had sine 15 degrees, you can simply change it to cos of 90 degrees minus 15 degrees. Once you see it's acute, you can just say 90 degrees minus that angle, which will be cos 75 degrees. So this is negative 15 degrees. It changes to negative cos 75 degrees, and then it's multiplied by a cos 75 degrees. And then over here, you see that cos 75 and cos 75 cancel in the numerator and denominator. Then we have plus sine 75 degrees multiplied by, and this is negative cos 15 degrees. We'll also change that. So we have cos 15 degrees. We'll just change it to sine 75 degrees, okay? Because we'll say 90 degrees minus 15. So that is negative sine 75 degrees, okay? And now that we have 75 degrees all through, let's just multiply. Here, those who multiply, they stay negative. So it's negative cos squared 75 degrees. These multiply and become negative. So negative sine squared 75 degrees. And you can already see they're clearly using the identity sine squared theta plus cos squared theta. We just have a negative common factor. So when we take it out as a common factor, -1, then what are we left with? Let's start with this second term, just so that the sine is before the cos. So we'll be left with positive sine squared 75 degrees. And then in this term, we'll be left with positive cos squared 75 degrees. And we can see this is our identity, sine squared theta plus cos squared theta. So it's equal to negative, and this is 1. And that is our answer. Moving on to the next question. Question 5.5 says, prove the identity. And you can see straight away that we're working with the left-hand side. So we'll say left-hand side is equal to, and let me rewrite the identity. And let's see how we can simplify this. Well, we have two terms. One is a fraction, one is not. But we can make this a fraction by simply rewriting it as sine x over cos x. So we have 3 cos x all over, and we have 1 plus sine x. And we're going to rewrite this as 3 sine x over cos x because of our tan x. And now you see that in order to rewrite them so that they have the same denominator and we can actually add them, because we can only add fractions with the same denominator, add and subtract, okay? What we can do is to make their denominators the same. Okay, but they have really weird denominators, 1 plus sine x and cos x. The only way they can be made the same is if the denominator, the common denominator, is cos x times 1 plus sine x. So this is using LCD. And now, what do we have in the numerator? Well, we're just going to look at the first term and say, hey, we were trying to make this denominator cos x multiplied by 1 plus sine x. So how do you get this denominator to look like this one? Well, you would do that by multiplying it by cos x. But whatever you do on the denominator, you need to do on the numerator. So what happens with this is that it gets multiplied by a cos x and becomes 3 cos squared x. Okay, and then we do the same here. In the denominator, we have cos x, but we need to ensure that the denominators are the same. So we're going to make it look like this. How would we do that? By multiplying it by 1 plus sine x. Okay, so if we did that, we would also have to multiply the numerator by 1 plus sine x. So this will become positive. Now you can actually just see it as multiplying it straight away at this point. So you would be multiplying the 3 sine x into the 1 to become positive 3 sine x, and then the 3 sine x into the sine x to become positive 3 sine squared x. Okay, and this is what we have. Okay, and to go further, you see that we have a cos squared x and a sine squared x. Let's put those together. So let's rewrite this as 3 sine squared x, and then we have plus 3 cos squared x. And the reason is because we know that cos squared x and sine squared x, when we add them, they give us that identity of 1. So we still have the plus 3 sine x here. And this denominator is better to not multiply it yet. Let's leave it like this because right now it's one term, okay? It is being multiplied by something with brackets. So this is one single term, and I want to leave it like that so that once we find the common factor, it can cancel with what we have in the denominator. Okay, so this is equal to 3, and we're going to just take, how about we're grouping these two together, and we can take 3 out as a common factor. So we have 3 out, and what are we left with? In the first term there, we are left with sine squared x, and then plus cos squared x. And we have plus 3 sine x, because we know that this will become 1. So rewrite everything the same. Okay, so now we can finally just turn that into a 1. So it's 3 times 1, which just stays the same, and we don't really have to rewrite it again. We can just do that. Okay, so you can rewrite it like 3 plus 3 sine x over cos x, and then 1 plus sine x. And now in the numerator, do you see that we have a common factor of 3? So when we take that out, we are left with 3 divided by 3 is 1. 3 sine x divided by 3 is positive sine x. And that is identical with what we have in the denominator. So this is 1 plus sine x, which is going to cancel with this. Numerator is 1 plus sine x. And indeed, this identity is equal to 3 over cos x. Just like the right-hand side, 3 over cos x. So it's finally equal to the right-hand side, and we have proven that the left-hand side is equal to the right-hand side. Moving on to the next question. Question 5.6 says, determine the general solution of sine squared x minus 3 cos squared x equals 0. Okay, we can create tan from this because we have squared x and squared x. Okay, it's not like x and then 2x, for example. So we have sine squared x, and we can just transpose this negative 3 cos squared x. So it becomes positive 3 cos squared x. And now to create tan squared x, we can simply just divide both hand sides by cos squared x, okay? Because sine over cos is tan. So cos squared x on both hand sides. And now we have tan squared x is equal to 3. And then to solve for tan x, you would square root both hand sides. But this is an equation, so you need to consider the positive and the negative solution, meaning tan x is equal to positive or negative square root 3. So these are two equations that we have. We have tan x is equal to the square root of 3, or tan x is equal to negative root 3. Okay, and here's how we can solve for this. So I'm going to use a simple approach. I'm not going to use that cos diagram, okay? And the reason why is because we're working with tan, and it's not necessary when we're working with tan. So finding the general solution, you can simply use your trig graph, okay, with a little bit of the calculator because you just need your reference angle. So let's find that reference angle first. Our reference angle here is simply going to be, if we have square root of 3, okay, it's like taking tan over. So you're going to use the second function of tan, and you're saying root 3. And if you did that on the calculator, you will get 60 degrees. That is 60 degrees. Okay, so this is 60 degrees, and here's how we can solve for this. So we're looking at the tan graph, and I'll actually just look at a tan graph. See, if you remember what the tan graph looks like, this becomes really simple. The tan graph repeats itself every 180 degrees, okay? So from 0 degrees to 180 degrees, it completes one cycle. We know that at 90 degrees, it will have an asymptote, and then it simply just goes up and then comes from being very close to the asymptote and then goes to 180 degrees, and that is our tan graph. So root 3 is a value that is positive. Okay, so let's say this was root 3, and we're just trying to find out within 0 to 180 degrees, where is the tan graph equal to the square root of 3? Where does it have a y value of the square root of 3? Do you see that from 0 degrees to 180 degrees, it only has a y value of the square root of 3 in one place, okay, within 0 to 180 degrees. And then this answer will repeat itself 180 degrees later, and then 180 degrees before this. We're just going to have this same graph repeating itself infinitely. So this reference angle of 60 degrees that we just found, that is what is over there. And here, just to solve for this, would simply say that, okay, this means that x is simply equal to 60 degrees. Okay, so the graph forever has y values of the square root of 3, where x is equal to 60 degrees, and then we'll say plus k of, and this tan graph repeats itself every 180 degrees. Okay, and of course, this is where k is an element of integers, and that will be my answer for this part. Now, I know if you use the cast diagram, you would have said, where is tan positive? And you would say in the first quadrant and in tan's quadrant. And then you would have taken that reduction and taken this. And then you're going to have a second solution that will say 180 degrees plus 60 degrees. This is not really necessary, okay? Because then you get 240 degrees. But let me show you where 240 degrees is going to appear in this diagram. If we extended this, okay, and then we got this graph again, you see that it's going to repeat itself 180 degrees later. So from 180 degrees to 360 degrees, you have another tan graph, okay, with the same shape, same pattern again. So there, the tan graph is repeating itself, and then it's going to have an asymptote, and then it's going to go like that again, okay. Where this 240 degrees is appearing is after this 180 degrees. Do you see that this line, okay, y equals square root of 3, it hits this graph here again. That's where the 240 degrees is repeating. And I see no use in repeating that. So that's the reason we can just leave it like that, because this is just a repeat of this same answer. 60 degrees, 180 degrees later is 240 degrees, which is just a repetition of your answer. So you can just leave it like that. You can leave the first sketch of the graph that you used to find this, and that's fine. Okay, and now looking at the second solution. So here, to find the reference angle would be found by saying, now I'm not using the Cartesian plane method where we ask, where is tan negative? I'm not using that method. So to find the reference angle of this is all you need to do. You just say shift tan and actually take the value you see here. It's the negative square root of 3. So we'll say negative square root 3, and we get negative 60 degrees. Do not worry about this. Yes, it is negative, but you can still make it positive. So you can decide to leave it like this. But if you wanted to understand it within 0 to 180 degrees, you can make it positive by simply adding. Now, the value we add here is the amount of degrees it will take this tan graph to repeat itself, which is 180 degrees. So we'll say plus 180 degrees. And you see that that would give us 120 degrees. So you could actually use this, okay, 120 degrees as your reference point. And so what this would show you, and here's the nice thing about this, you can use the same graph. You don't have to draw a new graph again. Okay, you can use the same graph because we're working with tan on both sides. And so when we're trying to find where negative square root of 3 would be, okay, where this graph has a y value of negative square root 3, do you see that this is where it hits the graph, okay, within 0 to 180 degrees. That is here at 120 degrees, okay? And so you can simply just say that x is simply equal to 120 degrees plus k of 180 degrees, because the tan graph repeats itself every 180 degrees, where k is an element of integers. And those will be your answers, okay? Those are the general solutions to this equation. And that is it for question 5. Question 6 says the graph of f is equal to cos x plus 30 degrees in the interval where x is an element of negative 120 degrees to 150 degrees has been drawn in the diagram below. Also notice that they've used square brackets here, which means that these are actual x values included in this interval. So we should also be able to consider the y value where x is equal to negative 120 degrees and the y value at 150 degrees as well. Those are actual included points. And the first question, 6.1, says, write down the period of f. Okay, so the period of a graph is really how long that graph will take to complete a cycle. This is a cos graph, and it's cos x plus 30 degrees. But notice it's cos x, not cos 2x, not cos half x. Okay, so it's still cos x, meaning that period has not been changed. It has not been tampered with. So the cos graph naturally takes how long to complete a cycle? The cos graph completes one single cycle in 360 degrees. Then 360 degrees later, it will have the same shape. And 360 degrees later, this same shape. Even 360 degrees before this. Okay, so that's a cos graph, meaning that this graph's period is simply 360 degrees. And that is our answer. Moving on to the next question. Question 6.2 says, write down the range of h of x if h of x is equal to f of x plus 60 degrees and then plus 1. Okay, this all depends on what range refers to. The range of a function would be all the possible y values that this graph has. Okay, all the y values of this graph. So let's look at the graph of f first and then see what changes was made here. The graph of f initially looked like this. It says cos x plus 30 degrees. So we see that we are adding 30 degrees, okay? 30 degrees being added to the x. Because you are adding to the x, this is either shifted to the left or the right. You have to decide on which it would be. But here it is. If it was shifted to the left, then we add, okay, when we are applying this to the equation. And when it's moving to the right, we subtract. So you see that this is simply a left or right movement, meaning that this graph was just shifted 30 degrees to the left. Now, shifting it to the right or the left, that's not going to affect the y values, okay? Because it's still going to a highest of 1 and reaching a lowest of -1. Shifting it right or left doesn't affect the y values. So the only thing that affects the y values would be if you shift the graph up or down. So from this question, you should see that, you see this x plus 60 degrees here, it's not going to affect your y values. So that's not even what we're bothered about. We will be looking at this. Now this plus 1 outside of this f of x, this is a shift, okay? But this is a vertical shift, meaning it's either moving up or down. If it was shifted up, we would add. If it was shifted down, we would subtract. So because this had a plus 1, it means that we simply shifted this graph up by 1 unit. So let's think about that graph, okay? That cos graph, the highest it reached was 1 and the lowest it reached was -1. So if this was 1 and this was -1, so if it was shifted up by 1 unit, then it means the lowest it will reach is now at 0 and the highest it will reach would be at 2. Okay, so your graph would look something like that. And so we can see that the range of this graph h is, it's going from 0 all the way to 2. That's all the y values that this graph will have, meaning y is greater than or equal to 0 but less than or equal to 2. You can also write it as y is an element of, you're going from 0 to 2, but because 0 and 2 are included y values, okay, y is actually equal to 0 and equal to 2, you would use square brackets for this. Okay, and those would be our answers. This graph simply just moves up to 2, highest of 2, and its lowest is no longer at -1, it's now at 0. Okay, so it will just look exactly the same like this, but it's been shifted up by 1 unit to look like that. And that would be the graph of h. Okay, moving on to the next question. Next question, 6.3 says, write down the equation of h in its simplest form. So at first we had to tell them what the range would be, but now we have to write the equation. So let's write the translation. They told us that h of x is equal to f of x plus 60 degrees and then plus 1. So let's get f of x, and this is f of x. Let's rewrite that here. And now we can apply this. So you see, wherever you see x, okay, this translation is saying, wherever you see x, add 60 degrees to it. And then when you see f of x, okay, the result of substituting x, meaning wherever you see your full y value, the full graph, you're simply just going to add 1 to this. So this is simply equal to h of x is, and we know that f of x is cos x plus 30 degrees. So we'll say cos x, and now we see x. So wherever you see x, you're going to add a 60 degrees to this. But we still have that plus 30 degrees. So rewrite it plus 30 degrees. And then you're just adding plus 1 to this, and it's outside the bracket, okay? So whatever we have here would give us the y values of this graph, right? And you're simply going to add 1 to this. So outside of the bracket, you say plus 1. And when we simplify this, we have h of x is equal to, this is now cos x plus 90 degrees. Or we can even write it as 90 degrees plus x, and then plus 1. Do you see that we have cos x plus 90 degrees? That is a cofunction. They want us to simplify this, okay? Write it in its simplest form. So it means that h of x is simply equal to, let's use the cofunction here, cos 90 degrees plus x is equal to negative sine x. And this is plus 1. So you can leave your answer as negative sine x plus 1 or 1 minus sine x. That's perfectly fine, and that is h of x. Moving on to the next question. Question 6.4 says, draw the graph of h of x on the grid provided in your answer book. Okay, let me just get that grid with this graph, really, because that's really what we're going to use. Okay, so here is our graph, and how we're going to draw this. It's negative sine x plus 1. But remember that before this, it was this, okay? So this is still the graph cos, and it's x plus 90 degrees. Now, this current graph that we have here, that is the graph of f. And the graph of f is cos x plus 30 degrees. So if you look at cos x plus 30 degrees and cos x plus 90 degrees, plus 1, of course, okay, because of that plus 1. What happened? How did we get from this to this? Well, you can first see that we have first added a 60 degrees, okay, so we had x plus 30 degrees, and then we said plus 60 degrees. So we're shifting this graph 60 degrees to the left, okay, plus 60 degrees. And then we added a 1, okay. So you can see what is going on here. All we have to do is think about what that would look like with this graph. So if this is the graph that we have, let's just mark out those important points. We need to make sure that this graph moves 60 degrees to the left and 1 unit up, and that's all we need to do. Okay, so marking our important points. We need to look at where the graph has a y value of 0, where it has a y value of a half. Okay, that's here and here. And where it has a y value of 1, because that's going to be the maximum. And then, of course, where it has a y value of negative 1 and negative a half. And if we can just move all of these points the way they should be moved, then we'll have our new graph. Okay, so there's no need to overthink this. We already knew that it came from this. Plus, I'm really trying not to encourage that whole method of, oh, just take this and then substitute x is negative 120 degrees, get your answer, and then negative 90, because then you're not actually learning how to draw your trig graphs. Okay, so here's what we have, and we're taking negative 120 degrees, and we know that we need to move 60 degrees to the left and 1 unit up. Clearly, it's not going to even appear in this interval that they have given us. Okay, 60 degrees to the left is going to be at negative 180 degrees and then 1 unit up. So that one is gone. But you can just put it as a reference point just so that you remember what the shape of your graph is still going to look like. Okay, so negative 180 degrees and 1, maybe it's somewhere over there. That has been moved. And then this point, negative 90 degrees, another important one. Okay, negative 90 degrees and a half. This is going to move 60 degrees to the left. Okay, so that is 30 degrees to the left at negative 120. And then another 30 degrees will land you at negative 150, which is also not within our interval, but it's going to be like that. Okay, and then it moves 1 unit up. So it's going to be up here. Okay, and then I'm going to skip this one just because of where it is. I'm only just trying to get those important points so that we can just plot that, and then it will still have the shape. Okay, so let's move to negative 30 degrees. If we go 60 degrees to the left, we get to negative 90 degrees. Okay, now negative 30 degrees had a y value of 1. So it's going to go 60 degrees to the left and then 1 unit up. So it lands up there. Okay, so that's where the maximum will be. And then 0, I also ignore 0 for now just because of where it is. Let's go to 30. And then we have 30 degrees, go 60 degrees to the left. Okay, 30, 60, this is where you are. So we're here now. And then this had a y value of a half. So now it moves 1 unit up and it has a y value of 3 over 2, which is 1.5. Okay, so that's where that is now. And then 60 degrees, another, yeah, I should have marked that. This is another important point, okay, because it has a y value of 0. We're starting at 60 degrees and then we're going 60 degrees to the left. So that's at 0, okay, so we're now at 0 and 0. And then 1 unit up, so now we are here. And that's where that point is. Then with 90 degrees as well, 60 degrees to the left lands you here, okay, but you were here, so over here. And then 1 unit up, and now we are on this point over here. And then 150 degrees, goes 60 degrees to the left, okay, and 1 unit up. So we are on the x-axis. Now, let me just draw this part out so that you can just see what these ones will be. And they really just repeat themselves, okay? So here we go. Let's draw that, sketch that curve. Okay, so like this. And now you see that what the graph is doing from here, okay, when it hits 0, if we move from 90 degrees to 30 degrees, that's 60 degrees to the left, right? You see that the graph has a y value of a half. Well, it will also have a y value of a half if you move from 90 degrees to 150 degrees, 60 degrees to the right. So it has a y value of a half over here as well. Okay, so we'll just have that point right there. And then we can just connect it. Okay, so we're just going to draw that, and it's also a curve that just goes up like that. Okay, and this is our graph. But just remember that your interval is from negative 120 degrees to 150 degrees. So you can just cut that part off. So I will literally just take that and from 120, cut that part off. And we don't have that. Okay, so this is what our graph looks like. And this is the graph of h. Okay, and that is it for this question. Moving on to the next question. Question 6.5 says, use the graph to answer the following questions in the interval where x is an element of negative 120 degrees to 150 degrees. And so the question is, for which values of x is f having a minimum value? Okay, so where does f, the graph of f, have a minimum value? Do you see that the way the graph of f goes? It goes here, it's moving up, and then it reaches this highest, this maximum value of 1. And then it goes down, and then it reaches this minimum value, okay, of negative 1. So this is the minimum value, but for which value of x does it reach this minimum value of negative 1? It reaches this minimum value of negative 1 over here at 150 degrees. You can even double check that by using the equation of f. You know that the graph of f says cos x plus 30 degrees. So on your calculator, you can actually just say cos x plus 30 degrees. So your x is the angle that you're using. We're checking, is it at 150 degrees? And you see there, we do have negative 1. Okay, so there, this is where x is at 150 degrees. And that is our answer. Moving on to the next question. Question 6.5.2 says, where will, okay, so for which value of x will h of x multiplied by f of x be less than or equal to 0? Okay, so you see that less than or equal to 0 means either negative or equal to 0. So we can see that if any of them are equal to 0, if any of them have a y value of 0, it will always work at that particular x value. Okay, so what we can focus on is how to create this negative value, this less than 0 value it will have. If h of x y values, right, if it had positive y values and it multiplied by f of x y values, which happen to be negative, then it will give us a negative value, a value less than 0. Another way this could happen is if h of x had negative y values and it multiplied by f of x positive y values, then it will also give us a value that is negative, which is less than 0. And of course, we can also accept any place where we see that they are equal to 0. So let's just not forget about that equal to 0 as well. So looking at our graphs, we're just looking for places where h is positive and at the same time, or for the same x values, f is negative. Okay, so looking at our graphs, where is h positive? So when we're referring to where is it positive, we're referring to the y values. Where are its y values positive? We have positive y values all through here and negative y values here. So if you see that the graph lies above the x-axis, it has positive y values. if it lies below the x-axis, it has negative y values. So we need to ensure that the graph of h is above the x-axis, and at the same time the graph of f is below the x-axis. So the graph of h is above the x-axis all through here. See, it's above this x-axis. Here's the x-axis, it's above it. Also all through here, okay? At 90 degrees, it's on the x-axis. So this is also an important point, because this means that at this value, at this point, the y value of this graph is equal to 0. And that's one of the requirements we're looking for. They can also be equal to 0. Either one of them can be equal to 0, and it's perfectly fine. When multiplied, they will give us 0 as well, because we're looking for less than or equal to 0. So let's use a vertical line to illustrate this. So when we're looking through, do you see that the graph of f, unfortunately, it has positive y values all through here. So we can't take this. For example, I can't take this x value of negative 90 degrees, because here the y value is positive, but here the y value is also positive. Positive times positive is positive, not negative. So I can't take that. However, there is a point that I'm ignoring here. Look at this. At negative 120 degrees, okay, we can see that f's y value is 0. So if you take 0 and you multiply it by this positive y value, you're still going to get 0, which is one of the requirements here. We're looking for where do their products, when we multiply them, where do they give us either 0 or value less than 0? So this is something we also have to consider. I'm just going to say, I'm going to take that there, so we shouldn't forget that as well. But when we move after this, okay, after negative 120, do you see that here that's positive and positive? It's not going to work. Positive and positive. It's still positive and positive all through until we get to this point over here. Do you see that at this point, this is where the graph of f hits the x-axis, okay? So it means that it has a y value of 0 at this point. So you're taking 0 multiplied by the graph of h, and its y value there is a positive number. And so when you multiply them, they will also give us 0. So we also are going to take that point as well. When we keep moving to the right from this point, you see that after this, the graph of f is now negative, and the graph of h is positive. When they multiply, they will give you a negative value. Still negative and positive, until the graph reaches 90 degrees. So it's also working all through here. And we can also just mark these points as well. It's also working from 60 degrees all the way to 120 degrees. And of course, it is working at 90 degrees as well, because at 90 degrees, the graph of h has a y value of 0. So 0 times this negative is still 0. Okay, so it's working all through here, and we're going to include that as well, from 60 to 120 degrees. But if we keep moving, do you see that till 150 degrees, this is actually working till 150 degrees, because at 150 degrees and all through here, the graph of h has positive y values. It's above the x-axis. Okay, so there's the x-axis, it's above the x-axis, and at the same time, or for the same x values, the graph of f is below the x-axis. So it works all through there as well. So these are the places that this works. It works at negative 120 degrees and from 60 degrees all the way to 150 degrees. And nowhere else. Everywhere else, you see that both graphs are just both positive. Okay, so that's not going to work. So that would be our answer. How we would answer them would be like this. We would say x is equal to negative 120 degrees, or x is greater than, you can see that it worked from 60 degrees, okay, and 60 degrees is included. It works at this point, and also 150 degrees is included. So we'll say x is greater than or equal to 60 degrees, but less than or equal to 150 degrees. And that is our answer. Okay, and we can accept it all through there just because they did say from negative 120 to 150 degrees. And that is our answer. Moving on to the next question. Question 6.5.3 says we need to determine the value of x or values of x for which f of x is equal to h of x. Where are these graphs equal? Where do they intersect? You see that all through, the only place they intersect is here, okay, at 30 degrees, and then nowhere else. So we can simply tell them there x is simply equal to 30 degrees, and that is our answer. And that is it for question 6. Question 7 says, in the diagram, VP is equal to PQ. So, and they're both equal to 5 units. Okay, so these two lines are equal and they are both 5 units. And then they tell us that PQR is alpha. So we have alpha over there, which is equal to SPV, which is also alpha. And SPR is beta. So this is beta. And we are also told that these lines are parallel. So PS is parallel to QR. SV is perpendicular to VP. So these are perpendicular. And the first question is to express PS in terms of alpha. Okay, so PS. PS is over here. How do we express this in terms of alpha? Well, you can just use this triangle because you need to express PS in terms of alpha, and alpha is in this triangle. So it's a right angle triangle, and we can express this using trig ratios. So we have to express PS, right, in terms of alpha. But in this right angle triangle, the only side that we have is VP. In relation to alpha, this would be the adjacent side, and this is the hypotenuse. So when we're using adjacent and hypotenuse, we're clearly going to use cos. So cos, we'll simply say that cos alpha is equal to the adjacent side, which is 5, over the hypotenuse, which is PS. Okay, and then now we just make PS the subject. You can just do this by multiplying both hand sides of this equation by PS to get it out of the denominator. Therefore, PS cos alpha equals 5, and then divide both hand sides by cos alpha. So PS is equal to 5 over cos alpha, and that is our answer. Moving on to the next question. Question 7.2 says, determine RP in terms of alpha and beta. So RP. Okay, so we're not using this anymore, but we're using this with RP. So you can either use this triangle over here, or you could use this triangle. Okay, let's decide. In this triangle, we have PS, which we found previously, which was in terms of alpha. And we have that. But seeing that this is not a right angle triangle, if we were using PS, then we would need to use the sine rule. We can use the sine rule, meaning you would need the angle opposite PS. Okay, and I have no idea what that is. And you see that to use beta, you would need SR. So this triangle may not be a good idea. Let's focus on this triangle over here. So to use PR, okay, we would need this angle opposite PR, which is alpha, and that's great. But you see that inside this triangle, we don't have anything in terms of beta. But remember that they have given us parallel lines. So these lines are parallel, meaning if you find alternate angles, those angles are equal. So that means that this angle, okay, by angle R, it's not really angle R, but it's angle QRP. This is also equal to beta. And so now we can use it like this. We can take PR, which is what we're looking for, and we can pair that with alpha, and then we can take beta and pair it with this available side PQ, which is right opposite beta. Okay, so that's how we can find, something for RP. So we can say RP, so we're going to take it as the side over sine of that angle, it's opposite. So that is RP over sine alpha. So over sine alpha, which is equal to, and we're going to have to take this as PQ, which is 5. So 5 over sine and this angle, which we still have to tell them what it is. So this is QRP or PRQ. So we have to tell them that PRQ is equal to beta as well, because we have alternate angles. We don't really need reasons here because this is not Euclid. So angle PRQ is equal to beta. And so that's why we're able to say 5 over sine of the angle opposite it, which is beta. So sine beta. And all you're doing is making RP the subject. You see that to do that, we need to get rid of this sine alpha. So multiply by sine alpha on both hand sides of this equation. And therefore, RP is equal to 5 sine alpha over sine beta. And that is our answer. You can also write 5 and then sine alpha over beta. That's fine. Moving on to the next question. And then the last question, 7.3, says, hence, show that the area of triangle RPS is equal to 25 times tan alpha over 2. So just RPS. Okay. So RPS is this triangle over here, RPS. And you can see why they were making us find these things. They made us find the value or an expression for RP and PS as well. Okay, so you can clearly see that they made us do this because we can use the area rule here. So because we have beta in the middle and then we have the side next to it and the other side next to it, we can find the area of this triangle. So we're saying that the area of triangle RPS is equal to, and the formula is a half multiplied by the side next to it, PS, and then the other side next to it, PR or RP. So PS times RP, and then multiplied by sine of the center angle. So the angle in between, which is beta. So that is beta. And now we can just expand. So this is a half. We'll just put it as a fraction because the others are also going to be. So PS, we previously found that was 5 over cos alpha. So this is 5 over cos alpha multiplied by RP, which is 5 sine alpha over sine beta. So 5 sine alpha over sine beta. And then multiplied by sine beta, because that was the center angle that we had. And all we're doing is simplifying. So this is going to be in the numerator. Let's just see what cancels first. You see that we're just multiplying all through. Sine beta and sine beta cancel. And now we have in the numerator, we are left with 25 sine alpha over, and in the denominator, 2 times cos alpha. That's all that's left, which will be 2 cos alpha. And this is 25 over 2, okay? And you know that sine alpha over cos alpha is tan alpha. So we can just rewrite it the way they did. They said 25, and then we can see that that becomes tan alpha, and then that's over 2. And that is exactly what they asked us to find. And that is it for question 7. Question 8 says, in the diagram, a lid with a hemispherical form seals an open cone. So this is the lid that we have, okay? It's in the shape of a hemisphere. The slanted height of the cone is 13 centimeters. The diameter of the cone and the hemisphere is 10 centimeters, okay? So they have the same diameter. The height of the cone is h centimeters. And then they give us some formulas here. Okay, let's just assign them, okay, to their respective shapes. It's better to just do that now so that that is out of the way. So where the volume is equal to 2 over 3 pi r cubed, okay, so you can see that if we had pi r squared, which is clearly the area of a circle, and then we have 2 over 3, and then pi was multiplied as well. That is the volume of the hemisphere, because we know that the volume of a sphere is 4 over 3 pi r cubed. Okay, so you see that it's always the area of the base times the height. But in this case, of course, that height would actually be of this hemisphere, because you're going from, if you had to put this like on the flat ground and this side was sitting on the surface, then this would be the height, which is half of that diameter. Okay, from the center to the circumference, that is the radius. Okay, and that's why we have r cubed there. So we know that this is the volume of the hemisphere. We'll just keep that there. And then this is the volume of the cone. Okay, as you can see, the height. Okay, that area of the base times the height. But we know that if you had to actually create a cylinder out of this, then this cone will take up a third of that volume. Okay, in that cylinder. So this is for the cone. So the next surface area, we can see that we have pi r squared plus pi r times that slanted height. Okay, so we're adding two areas. They're actually giving you the surface area of this cone because you need the outer part of the cone, and then they're also giving you the area of this flat side. So when calculating the surface area, you just need to take note of what exactly they ask you to calculate, and then we'll know which formula to use. Okay, so we can see that this is for the cone, and then this surface area, 2 pi r squared, that would be the surface area of the hemisphere, because we know that the surface area of a sphere is 4 pi r squared. So if we cut that in two, it's just 2 pi r squared. Okay, so that belongs to the hemisphere. Okay, so now that we have all of these down, let's answer the questions. So the first question is to determine the height of the cone. Okay, so here's the height. You can see that this height is perpendicular to this radius. Okay, so we know that to find the height, we can simply just use Pythagoras. So we'll say that the height squared, because it's one of the shorter sides, we'll say this is equal to the hypotenuse squared, which is 13 squared, minus, now you need to say minus the other shorter side. This diameter is 10 centimeters, so half of it, the radius, is 5 centimeters. So we'll say minus 5 squared. So the height is equal to, so that's 169 minus 25, which is 144. And then if we square root, we finally get that the height is equal to 12 centimeters. And that is our answer. Moving on to the next question. And then question 8.2 says, write down the height of the container. Okay, so the height of the whole shape. So that is from this highest points here all the way down to this point. So we already know this height. We know that this height is 12 centimeters. So what exactly is this height? Remember, this is the radius, okay? It's from the center to the circumference, okay, of this hemisphere. So if we know that the hemisphere's radius is 5 centimeters, we'll just say 12 plus 5. So just tell them that this height is, well, let me not call it height. Call it height of the container. It is just going to be 12 plus 5, which is 17 centimeters. And that is our answer. Moving on to the next question. Question 8.3 says, calculate the volume of this container. So of the whole container. So that would be the volume of the cone plus the volume of the hemisphere. Okay, so we already have our formulas and we're just going to say, so we're just going to take the volume of that cone plus the volume of the hemisphere. And let's just put those formulas down first. Okay, so that's what we have. And we can see that the radius that they're referring to is still this 5 centimeters. And then this height, okay, that we're referring to because it's the volume, that is the 12 centimeters. Okay, so we're just going to substitute. So this is equal to, we have 2 over 3 pi, and our radius is 5, so 5 cubed, plus 1 over 3, and then pi times pi, and then the radius again is 5, so 5 all squared, multiplied by that height of 12. And let's get our answer. Okay, so the answer is 550 pi over 3. And then we can just put this in decimal form as well. So as a decimal, this is 575 points, and we'll round off to 2 decimal places. So that is 0.96. And remember, it is the volume. So this is in centimeters cubed. And that is our answer. Moving on to the next question. Question 8.4 says, determine the total surface area of the container. So the total surface area, and let's look at that and just look at the formulas they gave us. You see, with this surface area, you need to just be careful. With the cone, you see how they say pi r squared plus pi r times the slanted height. Pi r times the slanted height is already the surface area of the cone, okay? That outer part of the cone. If you say plus pi r squared, you're going to be adding the area of this part, okay? This part of the cone. And we don't want that in this case. If you want the surface area of this entire container, then you're going to have to look at it as if you're painting this container. And so we need this part, so the outer part. So we need the surface area of this cone, right? The outer part of the cone, plus the surface area of that outer part of the hemisphere. So just make sure that you include, with the cone, just include the part that speaks about the outer part of this cone. And then with the hemisphere, that's fine. 2 pi r squared is the total surface area of the hemisphere. Okay, so let's go ahead and write our surface area. And so this is what it's going to look like. Okay, and so this is pi times the radius of 5 times the slanted height of 13 centimeters plus 2 times pi, and then that radius is still 5. Okay, so let's get our answer. Okay, and first in terms of pi, it is 115 pi. And then if we finally just put this in decimals, so this is 361.28 centimeters. Now remember, this is surface area, so it's still area, so centimeters squared. And that is our final answer. And that is it for question 8. Question 9 says, in the diagram, ABCD is a cyclic quadrilateral and O is the center of the circle. Use the diagram above to prove the theorem, which states that the opposite angles of a cyclic quad add up to 180 degrees. Then prove that angle B plus angle D is equal to 180 degrees. Okay, so that's our focus. We need to show that angle B plus angle D is equal to 180 degrees. Okay, so to prove this theorem, you first start off by drawing a line from the center to the circumference, or a radius at OA, and then a radius at OC, okay, from O to C. And just ensure that you tell them any constructions that you have made. Okay, so draw OA and OC. And now we're going to go ahead and name this angle O1, and this is angle O2. You see that the angle at the center, we're going to use this theorem that we know about the angle at the center and its relationship with the angle at the circumference, as long as they are supported by the same chord or arc. Now, in this situation, angle O1, right, it's supported by this arc AC, right? But as you can see, it's the shorter arc to this arc AC. So it's supported by this arc AC, and we can also see that angle B at the circumference is also supported by that same arc. So the angle at the center is twice the size of the angle at the circumference, as long as they are supported by the same arc or chord. So we'll go ahead and tell them that angle O1 is twice the size of angle B, and then put down our reason. Okay, and now we can also see the same relationship with this angle O2. Okay, so this is twice the size of this angle at the circumference. But we can also see that angle O2, right, it's supported by this arc AC. Okay, so that's a different arc. They may have the same name, but they're not the same. As you can see, they have different sizes. So this would be the major arc. It's the bigger one. So this arc is supporting angle O2 at the center, but it's also supporting angle D at the circumference. So it means that angle O2 is twice the size of angle D. Okay, so let's just put that down. We don't really need those markings. So we can tell them that angle O2 is twice the size of angle D, and it's for the same reason. Okay, now what do you notice about angle O1 and angle O2? They're both at the center. So if you added angle O1, take angle O1 and add it with angle O2, do you see that they create a full revolution? Okay, those angles will add up to 360 degrees. So we can just show them angle O1 plus angle O2 is equal to 360 degrees, because these are angles that lie around the same point. Okay, angles around the same point add up to 360 degrees. Okay, so there's our reason. And now, in place of angle O1 and angle O2, we can substitute what they are equal to. Our focus is on angle B and angle D. So angle O1 is equal to 2 angle B plus angle O2, which is 2 angle D, and this is equal to 360 degrees. So now, to find out the value of angle B plus angle D, you see that we have a common factor of 2 all across. And we can just divide both hand sides of this equation by 2. And so therefore, this concludes that angle B plus angle D is finally equal to 180 degrees. And that's how we prove this theorem. Moving on to the next question. Question 9.2 says, in the diagram below, O is the center of the circle with a reflex angle of 230 degrees. PQ R and S are points on the circumference of the circle with chord SR extended to point T. And then they tell us that QRT is 85 degrees and OPS is 20 degrees, so this angle over here. And we are told to calculate the magnitude of the following angles. So we just need to find the sizes, okay, the size of the following angles. And the first angle that we have is angle S. So let's look at where angle S is and then compare it to what we have. It is at the circumference. And immediately we can also see there's an angle at the center. They're using the theorem that they used above, okay, for this proof. Do you see how this angle is supported by this arc PR? And the angle at the center is also supported by PR. So it means that this angle 230 degrees is twice the size of angle S. So you can actually just write it like this, that angle, well, did they name it? Not really, they just called it a reflex angle. But if it is twice the size, then this is the bigger angle, that's the smaller angle. So we'll know that angle S is going to be half of whatever 230 degrees is. And we'll put down our reason because of the angle at the center is twice the angle at the circumference supported by the same arc, or chord, of course. So that concludes that angle S2 is equal to 115 degrees. Okay, moving on to the next question. Question 9.2.2 asks us to find the size of angle Q. And as we can see, you see where angle Q is? Right opposite angle S. Okay, so using the theorem above, okay, that we just proved, but the other one was using a theorem that we needed to use to prove this. So this is 115 degrees. It's always good to write down the angles that you find. And now we can find angle Q. So opposite angles of a cyclic quad add up to 180 degrees. Okay, these lie on the circumference of the circle. So we have a cyclic quad here. And so we can just say that angle Q is equal to, and we'll say 180 degrees minus 115 degrees. So angle Q is equal to, that is going to be like 70 minus 5, which is 65 degrees. Okay, so this is our answer. And then we should just also put the reason. So that was because of the opposite angles of a cyclic quad add up to 180 degrees. Okay, and that is our answer. Moving on to the next question. Question 9.2.3 says we need to find the size of angle P1. So looking at angle P1, it's way over here. So you see that together, this is now the angle that is the interior opposite angle. And we have an exterior angle of 85 degrees. So the exterior angle of a cyclic quad is equal to the opposite interior angle. So when we add these two together, they should give us 85 degrees. Okay, so that is 65 as well. So we'll say angle P1 is equal to 85 degrees minus that 20 degrees. So angle P1 is equal to 65 degrees. And the reason was because of the exterior angle of a cyclic quad. Okay, so that is our answer. And we can also just make sure that we put that down so we know that angle P1 is equal to 65 degrees. And moving on to the next question. Question 9.3 says, in the diagram, PQRS is a cyclic quadrilateral. And we have QA intersects SR at point A. And angle SAQ is 130 degrees. And we are also told that angle AQR is 20 degrees. And the question is to calculate, given reasons, the size of angle P. So this angle over here. How do we find that? Now, don't go start finding random things, because if you do that, you end up wasting time. Let's create a way or a strategy to find angle P. So because angle P is at the circumference and we have a cyclic quad, we can focus on using the opposite angles of the cyclic quad. So it means that in order to find angle P, we need angle R. So how do we find angle R? We can find angle R because do you see that we have this triangle over here? And this triangle has an exterior angle, 130 degrees. We know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So that's how we'll find angle R. So to find angle R, we can just say angle R is equal to, and we're going to take that 130 degrees minus 20 degrees, because when we add those two angles inside, they give us the exterior angle. And this is because of the exterior angle of a triangle. And so angle R is equal to 110 degrees. So we know now that this is 110. And now how do we find angle P? We know that the opposite angles of a cyclic quad add up to 180 degrees. So it means that to find angle P, we simply say angle P is equal to 180 degrees minus 110 degrees. And that is because of the opposite angles of a cyclic quad. And so therefore, angle P is equal to 70 degrees. And that is our answer. And that is it for question 9. Question 10 says 10.1, in the diagram, O is the center of the circle APB, okay, or ABP. And then they tell us that PB is extended to C, AC is drawn, and PN is a tangent to the circle at P. OC intersects AP perpendicularly at point O. And we are also told that angle P2 is equal to 37 degrees. So question 10.1.1 says, determine given reasons the size of angle O1. Okay, so we see that angle O1 is at the center. So think about theorems that refer to angles at the center. So we know that the angle at the center is equal to twice the size of the angle at the circumference as long as they're supported by the same chord or arc. So PB is this chord that supports both angle O1 and angle A1. So we'll know that angle O1 is twice the size of angle A1. So if we found angle A1, we would know what angle O1 is. So how do we find angle A1 now? Angle A1 is at the circumference. And do you see, okay, so this chord BP that supports it, it's also this chord that connects to this tangent. So we know that the angle between the tangent and a chord is equal to the angle supported by that same chord at the circumference. Okay, so there we go. We know that angle A1 is going to be equal to 37 degrees now. So angle A1 equals 37 degrees, and that is because of the tan chord theorem. And since this is 37 degrees, then it would mean that what is the size of angle O1? If this is 37 degrees, then angle O1 is just double of this. So 37 times 2 is 74 degrees. So we can just tell them angle O1 is equal to double the size of this. So 37 degrees times 2, which is 74 degrees. And this is because the angle at the center is twice the angle at the circumference supported by the same chord or arc. And that is the size of angle O1. Okay, and we also have the size of angle A1 as well. Moving on to the next question. Question 10.1.2a says prove that OACB is a cyclic quadrilateral. So if you want to prove that a shape is a cyclic quadrilateral, you have to think about theorems that refer to cyclic quadrilaterals. So if we are able to prove that, okay, we have a quad here, and if you notice that in this quad, let's say it has an exterior angle. So we're just going to extend that. If you notice that the exterior angle of this quad is equal to the opposite interior angle, then it is a cyclic quad. Second way you could prove that this is a cyclic quad is if you have a quad, and in this quad, you notice that the opposite angles of this quad, that they add up to 180 degrees, then this is a cyclic quad. And then the last way that you could prove that a shape is a cyclic quad is if you have the shape, it could also just be a quad as well. But as long as you notice that the angles supported by the same chord or arc, okay, so you could also just have these connecting as well. As long as you notice that the angles supported by the same chord or arc are equal, then this is also a cyclic quad. And it doesn't have to be all of it, like all the pairs. You just have to find one pair that is equal, and then you have a cyclic quad. So let's look at the shape they're referring to, OACB, and see what we can use there. So OACB, let me highlight that. Okay, so this is the shape, And straight away, just because of the way the lines are going across, you see that it will probably be easier to go with this one. Okay, so we'll just go for this one. And let's see how we can prove this. So with this, I'm just going to go straight for this, just because we were already told that OC intersects AP perpendicularly at point O. So if this is what intersects that line AP, then we have 90 degrees over here. And if we can show them that angle B1 is also equal to 90 degrees, just seeing that it's also formed by this line going across like that. If we can show that this is also equal to 90 degrees, then we will see that in this case, the angles supported by the same chord, AC, are equal. Okay, so that will be a cyclic chord. So you can also say angles in the same segment are equal. So let's look at that. Can we actually prove that this is 90 degrees? Yes, we can. Okay, so if you look at OP, this is a diameter. So a diameter will always support an angle that has a size of 90 degrees at the circumference. So if this is 90 degrees, then you know that this line PBC is a straight line. And so angle B1 will also be 90 degrees. Okay, so let's go ahead and do that. So we're just going to prove and show them that first, this angle, I don't want to call it ABP. Let's just call it angle B2 plus angle B1. So let's remove this. So angle B2 plus angle B3, that is equal to 90 degrees because we have an angle in a semicircle. Okay, so this is 90 degrees. We're going to tell them angle in a semicircle. And so we can see that angle B1, B2, and B3, they lie on a straight line. So angle B1 is also equal to 90 degrees. If we say 180 degrees minus this angle. So angle B1 is also equal to 90 degrees. And we can tell them angles on a straight line add up to 180 degrees. Okay, so because angle B1 is equal to 90 degrees, and we can just state that we already knew that this angle AOC is equal to 90 degrees. So if you like, you can just state what they already told you, but it's not necessary. We can tell them that we know this is 90 degrees. So AOC is 90 degrees, angle AOC is equal to 90 degrees. And this is because this has already been given. We were told specifically that OC intersects AP perpendicularly. So we were given that OC was perpendicular to AP. Okay, and so because these two are equal, because we have angle B1 being equal to angle AOC, this proves that we have angles in the same segment in this case. Okay, so there we go. It proves that the shape is a cyclic chord. So you can finally conclude, therefore, OACB is a cyclic chord. And this is because the angles in the same segment are equal. Or you could say it's because of the converse of the angles in the same segment theorem. Okay, so the difference is if you were proving that this is a cyclic chord, then you cannot be stating that, oh, it is already a cyclic chord, therefore I used angles in the same segment. No, we are proving that the angles in the same segment are equal, therefore it is a cyclic chord. So the other way around. Okay, and that is it for this question. Moving on to the next question. And then B says we need to prove that OC is parallel to PN. So you're trying to prove that lines are parallel. Think about theorems that refer to parallel lines. So we could use fun angles here. This will be the first guess. So if you can show that you have any fun angles equal, okay, then we have parallel lines. Okay, so if you can show that this angle is equal to this angle, then it means that the corresponding angles on these lines are equal. Therefore, the lines are parallel. Okay, so let's see which type of fun angles we can see here. So it's specifically OC and PN. Let me highlight those. Okay, you see that we could create co-interior angles, but then, yeah, that's just a little complicated because now you have the fine angle O2 and the fine angle P1, and yeah, we don't really have to do that. We could just use this Z that we see here, alternate angles. So if we can show them that angle P2 is equal to angle C2, then we have parallel lines here because the alternate angles will be equal. So how do we find angle C2? Okay, do you see from the previous shape? If this shape is a cyclic chord, then you also have angles in the same segment here. as well. So we can finally conclude that angle C2 is actually equal to angle A1, which is equal to 37 degrees. So angle C2, okay, angle C2 equals angle A1, and that was equal to 37 degrees, okay? Now, do you see that angle P2 is also equal to 37 degrees? Of course, we have to give them a reason here. This is because we have angles in the same segment, okay? And we can also see that angle P2 is also equal to 37 degrees. And this is not something we found. This is just something that was given initially. So we'll just tell them this was already given, okay? And so because they are equal, we're just concluding angle C2 is therefore equal to angle P2. And so therefore, these lines are parallel. OC is indeed parallel to PN because we have equal alternate angles on these lines. So therefore, the lines are parallel. Okay, so the reason can be equal alternate angles, and that will be fine. Or you can also say the alternate angles are equal. And that is our answer, and we have proven that. And moving on to the next question. Question 10.2 says, in the diagram, PAT is the common tangent of the smaller circle and the larger circle at A. And then we are told that A and B is the diameter of the larger circle with M on the circumference of the smaller circle. ASC and BC are chords of the largest circle and MS chord of the smaller circle. So this is a chord in the smaller circle. And then they tell us that M is the center of the largest circle. It is also given that the length of AM is P units. Let's just take this down. AM is P units and AS is P minus 1 units. BC is 6 units. Okay. And the first question, 10.2.1 says, name given reasons 3 angles equal to 90 degrees. Okay, let's look in our diagram. So in this diagram, first, I see that we have a line from the center of the bigger circle to a tangent. We know that the radius and the tangent are perpendicular at their points of contact, so that's 90 degrees. Now, with the larger circle, funny enough, this is 90 degrees for 2 reasons. Okay, it's 90 degrees because AB is a diameter, so I'm not really going to call it a chord. It's really 90 degrees because we have a diameter and it's supporting this angle at the circumference, so it's 90 degrees. But you can also look at this as if it's the tan chord theorem, okay? The angle between the tangent and the chord. Though this is not a chord, it's a diameter, but it still has the same function here because we have the angle between a tangent and a chord, okay? But you see how it's not really necessary to use that because you already know this is a diameter, okay? So that is the angle in a semicircle. I guess you could also just say that this is also 90 degrees. So that will be this angle BAT, and which is made up of 2 angles really. And what else? I'm just trying to see all the things that we could just capture that are equal to 90 degrees. Okay, do you see that angle S1 would also be 90 degrees because we have this tangent and then we have AM, which they didn't call it a diameter or anything. So we could just say it's the angle between a tangent and a chord, so it's equal to the angle supported by that same chord at the circumference. So it's also 90 degrees. Okay, so you see you have like 4 options that you could pick from. So I'll just name these 3. So angle A3 is equal to 90 degrees because we have the radius is perpendicular to the tangent. So radius perpendicular to tangent. And then we also have angle S1, which is because of the tan chord theorem. So angle S1 is equal to 90 degrees, and we can just tell them this is because of the tan chord theorem. And lastly, we have angle C, which is equal to 90 degrees, and that's because it is an angle in a semicircle. Okay, so angle in a semicircle. And those are our answers, and those would be the 3 angles equal to 90 degrees that we can find here. Moving on to the next question. Question 10.2.2 says, give a reason why MS is parallel to BC. So why is MS, this line over here, Why is it parallel to BC? Okay, the minute we start speaking about parallel lines, you can focus on fun angles first. So do you see that we have angle C and angle S1 being equal? So that creates corresponding angles. So they are parallel because we can see that the corresponding angles are equal. Okay, so we can go ahead and tell them that you just have to state. So angle C is equal to angle S1. So angle C equals angle S1, and they're both equal to 90 degrees. And so therefore we can say that this concludes that MS is indeed parallel to BC because we have the corresponding angles. The corresponding angles are equal. So, and that is our answer. Moving on to the next question. And then question 2.3 says, write down the ratio of AS is to SC with a reason. Okay, so let's just see the relationship between those lines, AS and SC. So this is AS and this is SC. And what can we see about these lines? Okay, so it's just one of the chords of this larger circle. And where is it? Okay, do you see that we have a center? We have a center at M, and we have, okay, and that is already perpendicular. We have the line from the center of the circle perpendicular to this chord AC, right? So if you have a line drawn from the center perpendicular to the chord, that line is going to bisect that chord, meaning AS is now equal to SC. Okay, and that's what we have there. So because they are of the exact same length, for example, if this was, let's say we just found that AS was 10 centimeters, okay, or 10 units. And so this would mean that SC is also 10 units. Right? So if you were writing this as a ratio and they specifically said write it as AS to SC, you would just write that length is to this length. And if you want to simplify it to make it a simplified ratio, you can put them over each other. You can put AS over SC, and so this becomes 1 over 1. Okay? So you can write it as 1 is to 1, and that would be the ratio. So let's go ahead and tell them that these two are equal first because we have the line from the center of the circle perpendicular to the chord, so it bisects that chord. Okay, so AS is first equal to SC, and put our reason down. Okay, and specifically saying perpendicular to chord, so it's not the line from the center to the midpoint of the chord. Okay, it's the line from the center perpendicular to the chord. That line bisects the chord. Okay, and now because of that, we can just conclude that this would mean AS is to SC is equal to 1 is to 1, and that is our answer. Moving on to the next question. Question 10.2.4 says, write down the length of MS with a reason. Okay, so the length of MS. If we have this and we have that these two are now equal, what is the length of MS? Okay, so from the shape they're giving you, this triangle, you can already see that they are pointing at the midpoint theorem. So this is pointing at the midpoint theorem. Okay, so here's the thing. Do you see that we have this AM and MB? If AB is the diameter of this largest circle, and we know that M is the center, then it means that AM is a radius and MB is also a radius. So these two are equal, and we'll have to state that first. Okay, so AM is equal to MB. So AM equals MB. And of course, this is because we have equal radii there. And so because they are equal, you can see that this is the midpoint theorem. You have this side, AM being equal to MB, AS equal to SC. So because we have that, we can conclude that these two lines are parallel. We already had that they were parallel though. But okay, these two lines are now parallel, and the length of BC is twice the size of MS. So this is the smaller one. If this is 6 units, then this is 3 units. And so we can finally say that it means that MS is equal to 3 units. And our reason is because of the midpoint theorem. And that is our answer. Okay, now in this question, I actually just want to, just state something here. We could actually have found this in 2 ways, and it would still be fine. Okay, so here I had to conclude these two because that was something that, we were not told that those are equal. We know they're equal because that's a radius and that's a radius. But you see that in the previous question, we saw that AS was equal to SC. So with this one, if I had said, it wouldn't really be necessary, but I could have also, just to ensure that I am pointing at the midpoint theorem, I could have also said AS is equal to SC and said that, yes, this has been proven in the previous question already. So in this case, I'm focusing on the fact that these two are equal and these two are equal. Therefore, the two lines are parallel, and also we know that BC would be double the size of MS. You could have also proven this, found the length of MS in this way. Instead of showing that AM and MB are equal, we could have avoided that and just used what we already had. In the previous question, we were able to prove that MS was parallel to BC. So we could have simply used that. So all we would have been using is the fact that we know these two are equal and these two lines are parallel. And so if you have these two sides being equal and the lines being parallel, then if you're finding the length of MS, this will not be because of the midpoint theorem. Rather, it will be because of the converse of the midpoint theorem. Okay, so here is what I mean by this so that you don't get confused by it. Okay, it's not really the same reason. So here's the thing. With the midpoint theorem, it depends on what you are given. Okay, depending on whatever you are given, you can conclude a certain thing. So let me also just add reason here. If we were given that this line AS was equal to SC and AM was equal to MB, then, so remember, this is what you have been given. AS is equal to SC and AM equals MB. Then what you can conclude from this is that first, SM is parallel to CB or BC, and that CB is twice the size of SM. Okay, and the reason here would specifically be the midpoint theorem, because that's the midpoint theorem we're using. Okay, the original theorem. Now, if what they had given you is that, for example, AS is equal to SC, it could also be AM being equal to MB, but let's just go with AS and SC because that's what we already had equal from the previous question. And we were also told that SM is parallel to BC. Okay, so this is what we have been given. AS equals SC and SM is parallel to CB. Okay, then what we would conclude from this, you would just fill it in. Okay, you see everything we have here, we're just filling it in. What else would we have here? Well, we would have, first of all, that AM is equal to MB and that CB is twice the size of SM. Now, the reason for this would be the converse. Okay, this is specifically the converse of the midpoint theorem. Okay, and that would be the difference. Okay, grade 11s, so remember that is the difference. The difference is specifically what you have been given. Okay, and then you conclude a certain thing based on what you've been given. Okay, and that is it for this question. Moving on to the next question. And then finally, question 10.2.5, the last question for this paper says, calculate the value of P. So let's look at P. To find P, let me just remove these. We don't need this anymore. To find P, how can we find P? Okay, P is part of this triangle here. We can just focus on this triangle then. Okay, this triangle over here. And we know that this is a right angle triangle. I don't know when I erased that 90 degrees, but it is over there. Okay, so this is a right angle triangle, meaning we can just use Pythagoras on this. Okay, so we're trying to find this and we can just say that this side squared plus this side squared is equal to that hypotenuse squared. Okay, so 3 squared plus, you can just write it out first. That's not a problem. Okay, so we can just see it here and we can just go ahead and say that we have ms squared, okay, plus as squared, and this would be equal to am squared, seeing that it is the hypotenuse. And our reason for this is because of Pythagoras. Okay, and now we can fill in. So ms is 3, so that's 3 squared plus p minus 1 all squared is equal to p squared. And we just have an equation and we need to solve for p. Okay, so this is 9. And when squaring this, you can write it as p minus 1 times p minus 1, but that takes a while. So we can just use this method. Square the first term, it gives you p squared. Square the last term, it gives you positive 1. First term times second term is negative p. Then times 2 is negative 2p. And there we go. And from this, you can see that the p's are going to cancel. So let's just transpose this, bring it over to the left. So it is now negative p squared is equal to 0. And so p squared and p squared cancel. And we have now negative 2p, and 9 plus 1 is 10. So positive 10 is equal to 0. We can transpose this to make it positive, but just take over the 10. That's fine. Negative 2p is equal to negative 10. And so therefore, we can divide both hand sides by negative 2. And p is finally equal to 5 units. And that is our answer. And that is the length of p. And that is it for this question. Okay, so that is the last question for this paper. It is a total of 150 marks. I hope you guys enjoyed it, and I'm wishing you guys all the best for your final exams. Make sure to leave questions if you have any, and I will see you guys in the future videos.